We introduce RFP, a new VR map implementation method for VR users to walk in a large virtual environment. There are a lot of methods for VR exploration. Such methods are using a joystick, teleportation, or natural walking. In natural walking, VR users can experience more sense of presence than that of others. In most cases, however, real space for VR exploration is often small and complex with many obstacles. For example, when a VR user walks into a large virtual space, the user can collide with the wall or obstacles in the real space. The VR user must avoid this kind of case. This is where redirected walking comes in. Redirected walking has two categories, subtle and overt. The subtle technique rotates the VR user's view so that the user can walk in a curved line. Thus, the user can avoid the wall of the real space. When the user reaches the physical boundary, the overt technique resets the user's direction. This reset is an explicit turn instruction for VR users. After getting the instruction, the user rotates in place, and then the exploration continues. However, current redirected walking methods using subtle techniques have a problem, that it does not maintain the correspondence between virtual and real space. So the user cannot predict when and where the reset happens, and accordingly, this kind of methods was not easy to be applied to a small and complex real space. This video is an example of the current redirected walking method, APF, with a complex real space. Here, blue line shows a boundary of the real space. We can observe the repetitive resets every time the user hits the boundary. Also, we can infer the unpredictability of the reset from the user's sudden stop after the reset instruction. These problems make the user difficult to be immersed in virtual reality. Then, how can we enable users to predict and reduce the reset? To solve this problem, we developed GRFP, which stands for Generating Virtual Space Using Reset at Fixed Positions. GRFP utilizes an advantage of substitutional reality that replaces real objects with virtual objects. To utilize GRFP, we extracted guaranteed space block, a walkable real space which is a unit block for making a virtual space. GRFP tiles the next guaranteed space block via pointer reflection about the predefined reset position. GRFP is based on the concept that matches a walkable real space and a walkable virtual space. With GRFP, the user can recognize the reset position in the virtual space and the corresponding virtual obstacles that match the real obstacles. The real obstacles can be furniture, pillars, or walls in indoor cases. Here we can see bushes, trees, and rocks which express such obstacles as a metaphor for users cannot pass. At the reset point in red translucent squares, users can choose whether they proceed to the next block or not. This video shows how the user walks with GRFP. There is no sudden stop anymore since the user can predict when and where the reset occurs. Also, we can confirm in the user's path that the user avoids the boundary of the real space. GRFP shows the user's higher walking speed and longer distance traveled between resets compared to the existing method. The simulation result also shows that the mean distance traveled between resets increases compared to the existing redirected walking method. To use RFP in a given virtual space, we also developed IRFP, which stands for Implementing Given Virtual Space Using RFP. The IRFP determines and minimizes the reset positions by tiling guaranteed space blocks according to a designed path. So VR users can explore with RFP even in a given virtual space. We combine the advantage of substitutional reality with the overt technique of redirected walking. So substitutional reality is extended to a wide space, and users are able to predict and execute the reset when they wish. From this benefit, we expect various industrial applications requiring walking tasks can employ our method. Thanks for watching.